So I have Chelsea, 小辉、雅雅、美仪、华拉乌、Christina、梁英、川红、Julia、曾瑜、Solilin、Season、吉宝、春晓、玉谷、金华、Sushila、李妍、I'm missing 美仪 Where's 美仪？对，我在找美仪，你在吗？你刚刚上来而已。Okay, I got everyone here. Okay, give me a second. BE102. Did you guys get all the answers for BE102? 你们的那个 BE102 你们有答案了吗？
I think the BE102 have a lot of questions, and there is some questions we are not read at.
You haven't learned the chapter yet. Have you learned chapter 7 yet, all of you? The basics of chemistry, yes or no?
I'm not.
我们是没学，我们是从
新的学生还没学，我是问旧的学生。梁英跟金华，你们应该是学了吧，对不对？
哪个
？Chapter 7, Basics of Chemistry， 就是那个化学物品。学了吗？
是学了，
对不对？学了，对不对？分子，
学了，
对不对？因为你们是学最久的，精华也是学了，对不对？
没有
啊，没有，你是几月几号加入课程的？
我是8月份。
啊，8月。
我是8月份。
等一下，我看一下我的 schedule。August。Chemical pure Manufacial8月份。August August.
可能是8月3号吧，我。
那你就是学了那个 eyebrow 跟那个 makeup， 对不对？
对。
Law and regulation. BE 102 health and safety consideration. BE 102 health and safety consideration. Health and safety consideration. Chemical ingredients. Economics. Okay, stop. Okay, stop. nail students, nail students, Christina, are you there? Can you tell me, do you have on electricity and do you have anything on electricity? Do you have a chapter on electricity? Health and Safety Consideration, California Board of Covering Article 12. Yes or no, Christina? 雅雅鹏，你在吗？雅雅
Let me find it. Hold on.
Okay. Health and Safety. Health and Safety, Article 12.
Yes, I do have.
You do have this chapter?
The basics of electricity.
Okay, have you learned this chapter?
Chapter 12, page 201.
Okay, have you learned this chapter? Yes or no?
Myself?
No, have you at the class? No, right?
No.
Okay. Okay, for nail students, 学指甲的, it's chapter 12. Okay, skincare students, turn to chapter 8. 学美容的 chapter 8. We're going to do basics of electricity. Everyone on basics of electricity? Okay, why study the basics of electricity? Because you have to have a thorough understanding of basics of electricity. It is a component of many services devices so that technicians practice proper safety precautions and procedures that do not endanger themselves or their clients. Okay, this one is on page 180. For nail students is chapter 12. Yaya, Peng, Jibao, Christina, you guys, you have to look for this chapter. Chapter says basics of electricity. And then Huara U, you have to look into your textbook and find basics of electricity.
Yes, I have.
You have it good, okay? Now, so that's the reason why we study basics of electricity, because a lot of our tools use electricity. Okay, so we need to know how electricity works. Okay, because most of the devices operate with electricity. So it's important to understand how electricity functions so you can use your device safely and properly. And also, you must have a good understanding of electricity. So, you know how to undergo upgrades and improvements, and also be able to transfer to a newer version. So over here on the side, it says that electricity travels very fast at 186,000 miles per second. Okay, so it you could go around the world 8 times in a couple of seconds. Okay, it's like turning off the switch of a light. Once you turn on the switch of the light comes out. That's how fast electricity works. And then one lightning bolt. This is lightning bolt. Okay, this is a lightning bolt. A lightning bolt has enough electricity to service 2,000 homes. Right? So lightning is part of as the effect of electricity. So if you plug in a poorly wired appliance into a socket and sparks fly out, okay, you're seeing the effects of electricity. So give me a second. So an electricity is the movement of particles around an atom that creates pure energy. Okay, that's electricity. So movement around an atom. If you know, everyone know what is an atom? Atom is the smallest particle. Okay, an atom, and then it makes up molecule. Okay, this one is found in chapter 7, which is under chemistry. Okay, this is an atom. Let me show you an atom. Okay, this is an atom. An atom is has negative charge and positive charge ions. Okay, so this is an atom. Atom is one of this atom. Okay, it's one of the smallest particle of an element. Okay, So this one is found on 163. So by joining two or more atoms, you make up a molecule. Okay, so electricity is the movement of particles around an atom. Okay, so the movement of particles around an atom is like this picture here. The movement around an atom. Okay, the movement of particles around an atom is actually electricity. That's why an atom has positive charge and negative charge. That is electricity. Okay, so an atom contains electricity, a negative charge, which is a negative ion, and a positive ion. So electricity is a form of energy. Okay, when in motion, it has some magnetic, chemical, and thermal effects. Now, magnetic, you know, right? Like a magnet, it also has the polar that attracts, you know, the opposite. So magnet, okay, is part of electrical energy. Okay, and then chemical, we know chemical effects. You know, when you add, just like when you do facial. I don't know if you've did facial before, but we did like what's the microcurrent, the machine microcurrent or galvanic machine. They make use of the chemical and the electrical charge. Okay, so that's a chemical effect. And then thermal effect will be heat. Okay, when you see the word thermal, it means it has to do with heat. Now, an electric current, it's the flow of electricity along a conductor in a complete circuit. If you look on page 181, this is a complete circuit. Okay? When you go in one full circle, it's called a complete circuit. Okay, so a electric current is the flow of electricity, okay, along a conductor. A conductor, what is a conductor? A conductor is any material that easily conduct electricity. That means what? You can get electricity by using the thing. For example, a good conductor will be metal. Metal is a good conductor. If you have metal, you can get electrocuted if you hold something metal, okay? Another good conductor of electricity is water, okay? Water is also a good conductor. So that means when your hands are wet, please do not touch any wires or plug in wires, you know, or touch anything that's electrical, because you can get electrical shock. Just like when you're swimming in the open, okay, and if there's thunder, get out of the water because you can get electrocuted. If there's a thunder, it hits the swimming pool or the pond or the river or that you're swimming in, you can get electrocuted because of the thunder. So water is a conductor of electricity. Okay, that's why you should not swim when there is an electrical storm. Okay, because electric current can pass through water and electrocute the swimmer. Okay, so and then the other one is called an insulator. Now, an insulator is also known as a non-conductor. It does not conduct electricity. Examples will be rubber, silk, wood, glass, and cement are good insulators. That means all this will not will absorb the electricity and you will not get electrocuted. That's why a lot of wires, if you realize a lot of wires, they are wrapped in rubber. Just like this wire here. The outside of the wire is actually made out of rubber. Okay, because why? This one is an insulator. The rubber itself is an insulator. That's why you won't get electricity. But if you look at the head here, this is metal. Metal takes in electricity. That's why it's a conductor. You understand? Okay. So that's the reason why a lot of wires, the head, it's all metal. It's because metal, okay, it's a good conductor. Okay, where else? Or copper. Copper is also a family of the metal. And then rubber is an insulator, which is a non-conductor. So you won't get electrocuted by touching the rubber, right? Okay, next one here is a complete. No, oh, sorry. Let's continue here. Electric wires are composed of twisted metal threads covered with a rubber, which I just showed you. Okay, so a complete electric current is the path of a negative and positive electric current moving from the generating source through the conductors and back to the generating original source or the ground. So the battery, it's considered the generating source because the battery is the one that gives the energy. And if you look on the battery, that's a plus, which is the positive. The minus is the negative. So when you want to light up a light bulb, you have to connect the light bulb to a positive charge and a negative charge in order for it to work. If it's missing any one of them, the light bulb will not work. That's why this is called a complete electric circuit. Okay, you need to have a complete, you have to have both positive and negative charge. Just like when, your car also has a battery. I don't know if you have jump-start a car before, but when you jump-start a car, you always want to connect the negative part first before you connect the positive part, and don't connect it wrongly. Okay? Then if you connect it wrongly, it can cause explosion. All right? So if you don't know how to do for car battery, it can cause explosion or sparks, catch on fire. So if you guys jumpstart a car, don't know how to do it, don't do it. Okay? Hydropower is actually water power. Okay? This is called hydropower. The water through the dam. In America, we have a lot of dams. Okay? We have dams is because it's to generate electricity. So that's the hydropower. The hydropower plants make up one of our largest our countries, which is US, a renewable energy source. Renewable, why? Is because the water gets recycled and we use it again and again to produce electricity. So hydropower plants rely on a dam that holds back water and creates a large lake known as the reservoir. Okay, so the water here that is being reserved before it goes down the dam to generate electricity, this water here it's called a reservoir. Okay, a reservoir is a place or a large lake, okay, that is used to collect water. The water comes from melting snows, from the mountains, or from rain, from streams and rivers, okay, or underground creeks, groundwater creeks. That means the water that comes from underneath the ground. Like people, they dig a well. The well is from the water under the ground. Okay, so those are called groundwater creeks. Now, when large doors on the dam opens, water flows from the reservoir pipe. As the water flows through into the pipe, it builds up pressure, which turns a turbine. A turbine is a large, it's a big disc with blades attached to a generator. So as the turbine blades turns, so do a series of magnets inside the generator. So giant magnets rotate past copper coils, producing alternating current by moving electrons. So the alternating current is called AC. You can see a lot of electrical adapters, they have AC. They will put AC. That means they need alternating current. It's converted into a high voltage current by a transformer. So going through the water plant large wires that become power lines, and then electric current pass through to supply electricity to the community. Just like the picture here, you can see the reservoir goes down the dam, and then it goes into a plant. This is the generator, okay, that converts the electricity. Inside here is where you have the turbine, okay, and the magnets to create electricity. And then from the generator, it travels through big wire poles, right? And then it provides electricity to your shop or to houses. I will show you a video of the dam. Give me a second. Hydropower. Okay, this is hydropower. Oops, give me a sec.
Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators.
Okay, that's the turbine. The water goes through it. This one turns. When it turns, that's called the turbine. When it turns, it creates electricity with the magnet. And the generator collects the electricity and converts it so you can use it. Okay? It converts the power into electricity. So in between here, that's where the magnet is. Okay?
The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production, dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier.
So you can see the water flows down, it spins the turbine, creates energy, collects by the generator, and then goes through the transformer. Why is it called transformer? It's because it transforms the energy that is collected to electricity, so it can supply it to the wire pole and then supply electricity to your homes.
Barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people.
The Hoover Dam is found close to Las Vegas. Okay.
All renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dam reservoirs can also help with flood control and be a reliable water supply for communities.
Okay, so this is...
In this animation, we'll look at how a hydro generator works. This is a typical New Zealand hydro station. You can see that the station has a dam which creates a drop from one water level down to another. From outside the station, we can't see the generators. If we approach, though, we can see the power lines or conductors that carry the electricity from the station to the national grid. Each power conductor connects to a turbine-powered generator inside the dam itself. Let's go inside the dam now and look at one hydro generator to see how the power is produced. The water from above the dam flows down through pipes called penstocks. Each penstock has its own headgate at the top to stop water flow for maintenance or during an emergency. At the end of the penstock is the scroll case. This curls around the turbine like a snail shell. It's designed to create a consistent pressure of water entering the turbine from all sides. Inside the scroll case is a set of vanes called the wicket gates. These control how water flows into the turbine. The wicket gates are controlled by an external governance system. This opens and closes them in response to conditions on the national grid. A high load on the system slows the turbine. The governor system reacts by opening the gates further to speed it back up. Conversely, it will narrow the wicket gates in response to low load on the system. Beyond the wicket gates, we can see the turbine blades. The blades are shaped to extract the most possible spin from the moving water. The turbine blades and the shaft connecting them to the generator are called the runner for each magnet. If they're switched off, the turbine will be able to spin without generating any electricity. The magnet's poles on the outside of the rotor create a separate rotating magnetic field for each magnet. The magnets are lined up so that adjacent poles always have opposite fields to each other, north, south, north, south, led towards the grid by conductors attached to the stator. Because the stator is connected to the grid, it's important that the pulses are in time with the grid frequency. When the
So this is how a turbine looks like, and inside there's the magnet and it spins. It uses the magnet to create power, and it goes through the wires into your generator, and then it goes into your electrical power. Okay, that's the hydropower. Okay, so that's how you get electricity. That's one way. Okay, it's safer than the nuclear power plant. Okay, nuclear power plant is dangerous. It's because if nuclear leaks, like what happens in, I think, Russia and in Japan, the nuclear power that makes electricity, when it leaks, it can cause cancer and kill people too. So hydropower is safer than nuclear plants. Okay, now types of electric current. Types of electric current, we have the direct current and the alternating current. Okay, direct current means one way. It's like when you're driving on the street, you only travel one way, so the current goes only one way. That's called direct current. So direct current is a constant, even flowing current that travels only in one direction. Examples would be like flashlights, your cell phone, cordless device, anything that is wireless. Okay, and that means doesn't have a wire. Okay, use direct current produced by batteries. It means anything that needs battery to run runs with direct current. Okay, anything that you operate with a battery, it's direct current. Okay, produced by battery. So the battery of your car stores direct current electrical energy. Without the battery, your car cannot start in the morning. Okay, that's direct current. Now a converter, it's an apparatus that changes direct current to alternating current. So what is a converter? For example, your iPhone or your iPad, you have like a little piece of thing that's your converter. because in order to charge your iPhone or your cell phone, you need to have a converter because you have to plug into the wall. Let me show you what's a converter. Give me a second. So this is your converter. Okay, this is an iPad charger. Okay, because when you want to charge your iPad or your iPhone, you need this. Because you have to understand, our cell phone works on battery, and battery is direct current. So in order for me to charge my battery, I need a converter so I can plug into the wall. Right? I can plug in to charge my phone. Because why? Because when you plug into the wall, the current on the wall is alternating current. Okay? All devices that use a plug, whether is it 2 or 3 prong. Okay, this is 2 prong. Okay? 3 prong means 3 pin. Okay? So that's why all devices that use the plug and connects to the end of electrical cord into the wall outlet, just like your hair dryer, your TV, your computer, anything that you plug into the wall. They use alternating current because alternating current is a rapid and interrupted current flowing first in one direction, then back into opposite direction, just like you're driving your car two-way street. One goes this way, one comes back this way. Okay, so that's alternating current. And this change, the direction of change is 60 times per second. That means within 60 every second it changes direction, because 1 second 60 times. So it goes up, back, up, back, up, back, up, back 60 times. Okay, one flows this way, one comes down this way. That's alternating current. So just remember, anything that runs on battery is direct current. Anything that you plug into the wall is alternating current. Okay? Yes? No? Okay? 明白吗? Hello? Everyone sleeping? You understand?
Okay, teacher.
Thank you for answering. What? What question do you have?
No. I understand. I understand now.
Okay. So anything that you plug in the wall uses alternating current. Anything that you use the battery is direct current. Okay. I'll show you a short video of.
Excuse me, teacher. Converter is the plug that what we plugging, right?
Yes, because okay, your cell phone. You want to charge your cell phone, right? Because your cell phone runs on the battery, right?
Yes.
Your cell phone uses direct current. Our cell phone uses battery. So our cell phone uses direct current because from the battery. But then the battery will lose energy, right? So in order to continue using it, we need to charge it, right? So in order to charge it, how we charge it? We need to plug into the wall to charge it. But in order to charge it, we cannot charge a battery without a converter. Why? Because anything that goes into the wall uses alternating current. It's a different current. So we cannot just charge the battery like that. We need a converter to convert the alternating current into direct current. Then we can charge our battery. You understand?
Okay, so supply the current, the medium called the converter.
Yes, the converter is the one that changes alternating current to direct current, because the battery can only take direct current. Yes?
Now I get it. Thank you, teacher.
Okay, you're welcome. So I'm gonna show you a short video of direct current and
built custom industrial machine.
If you were looking for a video on legendary rock music, you might have found the wrong channel. On a previous add-ons video, we looked at voltage, power, and current, and you might remember this animation. One problem with this animation is that the voltage source shown was an AC source, while the current flow was shown as DC. Let's talk about the difference between AC and DC. The letters DC stand for direct current, and it generally means the electrons flow in a single direction. AC stands for alternating current, and it means that the flow of electrons change. Now this is where things can start.
Can you see the video again? Direct current. Okay, let me show you.
Now this is where things can start.
One direction.
This is an AC voltage.
See, it goes one direction only. So this is called direct current.
Well, it turns out we tend to use AC and DC abbreviations for voltage as well as current. So in other words, AC, voltage or current, is voltage or current that changes. DC, voltage or current, is voltage or current that is steady. Okay, so let's take a little bit closer look at these two, starting with DC. Check out this AA or LR6 battery. It provides 1.5 volts. This example circuit is going to be a DC motor like you might find in a toy car. When we insert the battery into the circuit, current begins to flow in a single direction, turning the motor. If we do a graph,
so one direction, that's called direct current.
The horizontal axis is time. We can see that the voltage at this point stays constant. Now, since this is a battery, eventually it's going to run out of energy, and its output voltage will drop. So we know that the voltage will change over time, but the polarity will stay the same. So what is polarity? Well, polarity defines the positive direction, and for a battery, the positive voltage is created from the positive terminal. So what would happen if we turn this battery around? Well, that reverses the polarity, which means the current will flow in the opposite direction as before, causing our motor to spin in the opposite direction. Okay, so let's move on to AC, and in this case we're going to use a light bulb and a North American AC socket because, well, I live in North America. Notice how the circuit behaves when we turn the switch on. Let's break down what we're seeing by using the voltage graph again.
You can see the current go up and down, up and down. It's because it's alternating.
Right. Once the voltage reaches its peak, current flow stays the same, but the voltage begins to drop, and the light bulb gets dimmer. Once we reach 0 volts, the voltage's polarity changes, causing current to flow in the opposite direction. And again, as the voltage gets closer to its peak, the bulb gets brighter and then dims back down.
Okay, this is alternating current. It goes two directions. This up and then down.
It's called a cycle. The rate at which the cycle repeats is frequency.
Okay, so now you understand what is alternating current now? It will go one way and then the other way, one way and the other way, and it changes 60 times in 1 second. All right, okay? So that's alternating current. Okay, now, what is the rectifier? Okay, so we know what is the converter. The other one would be a rectifier. I'm sorry, this is a rectifier. Sorry, Sushila, this is a rectifier. Okay, this is a rectifier. A rectifier changes AC to DC. A rectifier. Okay, Sushila, this is a rectifier.
Yes.
This is the apparatus. 刚才我讲错了哈，这个是叫做 rectifier， 因为这个 rectifier changes AC to DC because we plug in the wall is AC, and then we charge the battery, so we change AC to DC. So this is a rectifier. A converter is it changes direct current to alternating current. So that's the difference. So at converter change the DC to AC. Rectifier changes AC to DC. Confused? Not confused?
No, but what is the example of converter?
Okay, let me show you an example of a converter. Oops, converter. Let me show you a picture of a converter. Converter DC to AC. I need to show you a picture, otherwise you won't understand. This is how usually a converter looks like. It's bigger. It's like a big box. Okay. This is I guess this one you can see in your laptop.
Yeah, laptop.
Okay. So it changes DC to AC. Okay. So
I think we need to yeah,
but anyway,
I think there is a two plug. There is a wire, and both sides have a needed to plug it.
This one is a rectifier. It has it. Okay. This is a rectifier is because it converts AC. You plug in to charge your battery for your cell phone. So that's why to recharge your battery. So this is a rectifier. Whereas a converter is something converter DC adapters converter. Where is the DC? They don't have a picture DC to AC. I don't see a DC to AC converter. All these are AC to DC, not DC to AC. DC to AC converter. Give me a second. Cut. No, sorry, I can't find any picture that shows DC to AC. All I see is just like that. DC to AC, a converter. This is the converter. It changes the battery, the one direction current to a two-way direction current.
Another example is multi-plug. What is that?
Example would be, let's see, example would be, some of the appliances you can work on battery and you can also plug in some of the appliances you have at home, you can either run with battery. If you don't have battery, you can just charge it to the wall.
Oh
Can you think of
yeah, some lights are tube lights are charging, and some are using the battery too.
yeah, so you have some of the electrical appliances you can actually run with battery. Okay, and you also can run. You can also plug in and run it. So but it uses a lot. So the battery you put in, sometimes you need like 4 batteries, or or 6 batteries. But then if you don't have battery, you can plug it into the wall too. Oh, let me think of something. Let me see. Electrical appliances that uses battery. Nothing. Not helpful today. I go. Anyway, I'll try to look for a picture and show it to you later, okay? Right now, I cannot find it on the internet, all right? But anyway, let's just continue here first. I just need you to understand a converter is the one that changes direct current to alternating current, and the rectifier is one that changes AC current to DC current. Okay, so this is a rectifier. Because you plug in the wall, you take in AC current and it converts into DC current into your battery. Okay, your cell phone battery. That's the rectifier. Okay, and alternating current is plugged into the wall. That's alternating current. And then if the electricity is from the battery, it's direct current. Okay, so alternating current comes out from the wall. You charge it, and then DC current comes from battery. That's all you need to understand. Converter. How come I cannot find converters? Okay, and then next one here is electrical measurements. The flow of an electric current can be compared to water flowing through a garden hose. Individual electrons flow through a wire the same way that the individual water molecule flows through a hose. That's what it means. When you turn on your tap, you have a pipe. Okay, a pipe or called a hose. When you turn to low, your water flows down slow. When you turn your tap high, your water flows out, shoot with power. Same thing, if your electric power is low, you will see low amperage. When your electric power, especially when you plug in the wall, it's high amperage. Okay, that means the voltage from your battery, it's low amperage. The plug-in has high amperage. That's what it means, the power. So that's how you measure electrical movement. You measure it with voltage. Okay, a volt, or also known as voltage, is the unit that measures the pressure or force that pushes the flow of electrons forward through a conductor, much like the water pressure that pushes the water molecules through the hose. Okay, so car batteries have 12 volts, where else, like your hair dryer or the iron, okay, has 110 volts. So when you can see the volts, right? Usually when you buy electrical appliances, it will tell you how many volts of electricity it will use, right? Yes, no, maybe so. For example, you have the iron. Let's see, 烫斗, okay, and iron to iron your clothes. Okay, it will show you on the thing how many volts you use. Or let me see if I can find it here. Okay, for example, this one, you can see the light bulb. It's 120 volts. Okay, that means it will produce, this light bulb will produce 120 volts of light. Okay, so because this one, why? This one actually plugs onto the wall like that. This is a big bulb, so it needs 120 volts. Okay, so that's the voltage. So everything that you buy, you will be able to see this. It tells you whether you use 110 volts, 120 volts. In Asia, I believe it's like 230 volts. In Asia, it's even higher. Okay, like China, Singapore, Malaysia, all those Asian countries, Japan, they all use double the volt. They use 230. It's only in America we use lower. We use 110 to 120. Okay. That's why when you buy a TV in America, you cannot use it in Asia. Okay, you cannot use it in Asia. So, because the TV that we produce here in America, it's only about 100, the voltage is different. In America, okay, I gotta tell you one more thing. In America, we have this right to the it's different. Yeah, it's different. The plug we use here in America is the three pin plug, right? Yes. But in Asia, you cannot use the 3-pin plug. You need a converter. You need a converter. Okay, so
many difference.
Yes, so that's why that's why manufacturers have to make something for America only, and then they have to produce. Like for example, you buy a shop TV, okay? A shop TV in Asia and a shop TV in America is different because the plug is different. Okay, so it's because of the voltage. Because in America, the voltage that we plug into our wall, this one here, the voltage that we plug in the wall, it's lower than the voltage in Asia, right? So now bigger appliances like the washing machine and clothes dryer, they run higher. They run double. It's 220 volts. So a higher voltage indicates more pressure on the faucet. Okay, so next one is ampere. Okay, ampere is also known as amp in shop. Okay, amp represent ampere. Is the unit that measures the amount of electric current. That means the number of electrons flowing through a conductor. You see, this is the electron. The little dots are the electrons. Okay, so the amp, okay, is the number of electrons that flow. For example, a hair dryer is rated 12 amps. Okay, so they must have a cord that is twice as thick as one that's rated for 5 amp. So you can see sometimes wires, they're very thick. It's because the thicker the wire, the more amps is required. The thinner the wire, the less amps required. Okay, that's why sometimes why you see some wires are very thick. For example, like I have a wire here that is very thick. Why? Because this one is my computer's wire. Okay. Oh, I know why. Oh, this is my monitor. Okay, this is the monitor. This is my adapter. Okay, for my monitor, and you can see the wire is thin. It's thick. But compared to the wire to the iPad, it's thin. Why? Because the iPad requires less amp, whereas this one here that is connected to my screen requires more amp. Okay. Now, if the cord will overheat, okay, and may cause a fire if you don't have enough cord. Okay, because too much power is required. Let's say the washing machine requires a lot of, it requires 220 volts, but your wire is thin. It's not drawing enough energy, and that can cause overheating and start a fire. That's why the bigger the machine, the thicker the cord. It's because the thicker the cord, the more wire is required to draw out electricity. Yes, understand this part? Okay, so the next one is milliampere. Milliampere is 1,000 here, 1/1000 of an ampere. Okay, that's why it's called milliampere. So you need 1,000 ampere to make up 1 ampere. Okay, you need to use 1,000 MA equals to 1 amp. Okay, so that's why it's 1/1000. So you need 1,000 MA to equal to 1 ampere. Okay, because 1 MA is on 1/1000 amp. Okay. So for example, if you do a facial or scalp treatment, the electrical current is measured in milliamperes. Okay, because an ampere current is too strong and will damage the skin or body. So that means whenever we use machine like this, like the high frequency or the microcurrent, the microcurrent, the electrical measurement we're using is only milliampere. It's not even 1 amp. It's less than an amp. Okay, so anything the electrical equipment that we use on the skin uses milliampere. Okay, now this one here is an ohm. What is an ohm? An ohm is a unit that measures the resistance of an electrical current. Current will not flow through a conductor unless the volts or the force is stronger than the ohm. Okay, we already understand, right? When you turn on the tap, if you turn it low, the pressure is low. When you turn on the tap, the pressure is, when you turn on big, then the pressure is strong. So there is a resistance. Resistance means what? It stops the flow. When we turn on the tap is the one that controls the resistance. So if the flow, again, the current will not flow through a conductor unless the force is stronger. That means you have to have strong current, okay, in order for the electric current, okay, to work well. Okay, so that's why there is a measurement called ohm. Ohm is a unit to measure the resistance of an electrical current. And then the other one is a volt. And a volt is the measurement of how much electric energy is being used in 1 second. Now, when you pay your electrical bills, I don't know if you see Southern California Edison bills before, they bill it in kilowatts or watts, okay? Most likely the house, they bill you in kilowatts, okay? Southern California Edison will bill you in kilowatts. So that's what you use in your house, okay? It's measured. Why kilowatts? It's because 1,000 watts how many, okay? So 1 kilowatt is 1,000 watts. So your house is being built by kilowatts per hour. That means in 1 hour, how much electricity you use. For example, a 1,000 watt hair dryer uses 1,000 watts of energy per second. So if you have a 40 watt light bulb, it uses 40 watts of energy per second. Okay, so for example, this light bulb is 42 watts. See here, 42 watts. W means watts. That means this bulb uses 42 watts per second. Okay, so next time when you see the word volt, you know, okay, how much electricity is being used per second. Most of the things that you buy nowadays, you see watts, especially light bulbs. Okay. Okay. Any questions here? No questions. Let's go for a break. Come back at 12:05. 如果你们没有问题的话，我们12:05回来。Let's go for a break. Come back 12:05.